In the summer of 1942, somewhere in the western desert of North Africa, a British sergeant of the Royal Army Service Corps watched a 30-ton Valentine tank burn. The tank had taken a hit from an 88mm shell during the fighting around Gazala. The crew had bailed out. The fire had consumed the engine compartment and blackened the turret. But the hull was intact. The running gear was intact. The gun was intact. If you could get this tank to a repair depot 60 miles behind the lines, a team of fitters could have it fighting again in a week. But you could not get it there. That was the problem. The tank sat in the open desert, a mile from the nearest track that passed for a road. The sand was soft. A standard truck could not move it. A tow from another tank was possible, but towing a dead tank through soft sand consumed the towing tank's tracks, its engine, its fuel, and its crew's patience at a rate that made the exercise barely worthwhile. For every damaged tank you recovered by towing, you risked wearing out the tank that was doing the pulling. The arithmetic was ruinous. You spent one working tank to save one broken tank and ended up with two tired tanks instead of one fresh one. What the British needed was not a tank. They needed a truck. But not any truck that existed in 1940. They needed a truck that could carry a 30-ton load across desert sand, up mountain roads, through mud that swallowed ordinary vehicles to their axles. They needed a machine that was part truck, part crane, part locomotive, a beast of burden so powerful and so heavy that it could drag a dead tank out of a ditch, winch it onto a trailer, and haul it 50 miles to a workshop without breaking a sweat. They needed a vehicle that no one had ever built because no one had ever needed one. Tanks had existed for barely 25 years. The idea of recovering them from a battlefield instead of simply abandoning them was a concept so new that most armies had not even thought about it. The British thought about it because they were losing tanks faster than they could replace them, and every burned-out hull left in the desert was a weapon that would never fire again. So in 1940, the British Purchasing Commission walked into the offices of American truck manufacturers and asked a question that made the salesmen stare. Could anyone build a truck that could pull 45 tons? The company that answered was Diamond T, a truck manufacturer in Chicago founded in 1905 by a man named C.A. Tilt. The company's name came from Tilt's father, a shoe manufacturer who had used a diamond as the emblem of quality on his products. The T was for Tilt, the diamond was for excellence. It was a modest name for a modest company that built solid, reliable commercial trucks, the kind of trucks that hauled freight across the Midwest and delivered coal and lumber and steel to the factories of industrial America. Diamond T had been building military trucks for the U.S. Army Quartermaster Corps for years. They understood heavy-duty construction. They understood low-speed torque. They understood the difference between a vehicle designed for paved highways and a vehicle designed for roads that barely existed. When the British described what they needed, a 6x4 tractor capable of pulling a 45-ton trailer loaded with a tank across the North African desert, Diamond T had a prototype nearly ready. The result was the Diamond T Model 980, a vehicle that looked like no truck on any American highway. It was powered by a Hercules DFXE diesel engine, one of the few diesel-powered American military vehicles of the war, a 14.5-liter inline-six that produced 185 horsepower at a lumbering 1,600 revolutions per minute. The torque, 685 foot-pounds at 1150 RPM, was enormous, the kind of pulling power that moved mountains one gear at a time. The transmission was a 4-speed main gearbox mated to a 3-speed auxiliary, giving 12 forward speeds and 3 reverse. The lowest gears were so low that the truck could crawl at walking pace with the force of a locomotive. Behind the cab sat a Garwood winch rated at 40,000 pounds, capable of pulling a dead tank through sand and up a loading ramp onto the M9 trailer that the Rogers Company built to carry the load. The trailer itself was a 12-wheeled flatbed with a loading ramp that dropped from the rear. The combination, tractor, winch, and trailer, was designated the M19 tank transporter, and it was the first purpose-built tank recovery system in the history of armored warfare. The first batch arrived in Britain in 1942 and was immediately shipped to North Africa. Within weeks, the Diamond T had proved itself in the harshest conditions imaginable. Desert sand that bogged lighter trucks, temperatures that blistered paint and cracked rubber, roads that were nothing more than tracks worn into the hardpan by camel trains. The Diamond T ground through all of it. Its crews, Royal Army Service Corps men trained to operate a vehicle that weighed more than most houses, learned to love the machine the way a farmer loves a draft horse. It was not fast, it was not beautiful, but it pulled, and it never quit. Over 5,800 Diamond T transporters were built by 1945. They served in every theater of the war: North Africa, Italy, Northwest Europe, Burma, and the Pacific. The British Army took delivery of roughly 1,000 and used them well into the 1950s, finally replacing them with the Thorncroft Antar. General Eisenhower, surveying the wreckage on the Normandy beaches after D-Day, saw Diamond T transporters hauling destroyed Shermans off the sand and onto the roads behind the beachhead. The tanks that had been knocked out on the morning of June 6th were in repair depots by June 8th, being rebuilt to fight again. Without the transporter, they would have rusted where they fell. The Diamond T was magnificent. It was also, by 1943, insufficient. The problem was weight. The Sherman tank weighed 30 tons. The Diamond T could handle that. But the new tanks coming into service, the M26 Pershing at 43 tons, the British Churchill at 40 tons, and the rumored German heavies that intelligence reports suggested might weigh 60 tons or more, were pushing beyond the Diamond T's design limits. The M9 trailer was rated for 45 tons, but loading a 43-ton Pershing onto it left almost no margin, and the Diamond T's 6x4 drivetrain, with only the rear two axles driven, gave it limited off-road traction. In the desert, the ballast box behind the cab could be loaded with sand or stone to put weight on the drive axles, but in the mud of France or the mountains of Italy, the Diamond T sometimes could not reach the tanks it was supposed to recover. The U.S. Army needed something bigger, something with six-wheel drive, something with an armored cab that could survive small arms fire and shell fragments, because the recovery crew would be working on the battlefield, not behind it. Something with winches powerful enough to drag the heaviest tank out of the deepest ditch. They needed a monster. The contract to build that monster went to one of the strangest companies in the history of American war production. Pacific Car and Foundry of Renton, Washington was not a truck manufacturer. It was not an automobile company. It was not a defense contractor. Pacific Car and Foundry built railroad cars, freight cars, logging equipment, heavy industrial machinery for the timber and mining industries of the Pacific Northwest. Its workers were men who built things measured in tons, not pounds: steel-framed boxcars, logging trucks, ore carriers. They worked with overhead cranes and riveting guns and cutting torches in a factory designed for objects the size of a house. The design for the new transporter came from the Nucky Truck Company of San Francisco, a small firm that specialized in heavy-duty trucks for the mining and quarry industries. Nucky's engineers understood what a military tank transporter needed because they had spent years building trucks that hauled rock and ore through the worst terrain in the American West. Their prototype was a 6x6, all six wheels driven, with a chain-drive rear bogie that was essentially borrowed from the mining industry. It was crude, massively overbuilt, and powerful beyond anything the military had seen on wheels. But Nucky was small. They could not produce the vehicle in the quantities the Army demanded, so the contract went to Pacific Car and Foundry, the railroad car company, which had the factory space, the heavy equipment, and the workforce to build an armored truck the size of a locomotive. Production began in April 1943. The vehicle was designated the M26 tractor. Paired with the M15 trailer built by the Fruhoff Company, America's largest trailer manufacturer, a company that had been building semi-trailers for the trucking industry since the 1910s, the combination was designated the M25 tank transporter. The soldiers who first saw it gave it a different name. They watched the enormous machine roar to life, its 17-liter Hall-Scott 440 gasoline engine belching flames from the exhaust with every ignition cycle, raw fuel combusting in the manifold, shooting orange fire into the air like the breath of a mythological creature. They called it the Dragon Wagon. The M26 Dragon Wagon was not a truck in any ordinary sense of the word. It was a piece of industrial equipment that happened to have a steering wheel. The engine was a Hall-Scott Type 440, a 1,090 cubic inch inline six-cylinder gasoline engine that produced 240 horsepower at 2,000 RPM and, more importantly, 810 foot-pounds of torque at 1,200 RPM. This was the largest gasoline engine in any military truck of the Second World War. It was not a refined engine. It was not a quiet engine. It drank gasoline at a rate that made supply sergeants weep, approximately 1 mile per gallon under load, sometimes worse. It was loud enough to be heard a mile away and hot enough to cook an egg on the exhaust manifold. The flames that erupted from the exhaust, the dragon's breath that gave the vehicle its name, were visible at night from hundreds of yards, a pyrotechnic advertisement of the vehicle's presence that no amount of tactical discipline could suppress. The transmission was a 4-speed main gearbox coupled to a 3-speed transfer case, providing 12 forward speeds and 3 reverse. The lowest gear ratios were designed for pulling loads that would have stalled any conventional truck. The chain drive system, the rear 2 axles were driven by heavy-duty roller chains from the transfer case, a technology borrowed directly from mining trucks, was the Dragon Wagon's most distinctive and most problematic feature. The chains required constant lubrication. They were self-lubricating in the sense that they ran in an oil bath, but the oil had to go somewhere, and where it went was onto the road. Dragon wagons left a trail of oil behind them wherever they drove, marking their passage with a slick, dark stripe on the pavement that persisted long after the vehicle had passed. The cab was armored. 3/4-inch steel plate on the front and sides, enough to stop rifle bullets and shell fragments. The roof was open. The crew needed visibility, and an enclosed armored roof would have turned the cab into an oven in summer. 7 men crewed the vehicle, a driver, a co-driver, and 5 additional crew who served as mechanics, winch operators, guides for reversing, and lookouts. The vehicle was so large and so difficult to maneuver, especially on the narrow European roads of 1944, that the additional crew were not a luxury, they were a necessity. 2 men walked ahead of the truck, guiding the driver around obstacles and oncoming traffic. 2 more watched the trailer. The 7th operated the winch. The winch system was the Dragon Wagon's reason for existence. 2 rear-mounted winches, each rated at 60,000 pounds, were mounted behind the cab. A 3rd winch in the front, rated at 35,000 pounds, was intended for self-recovery, pulling the Dragon Wagon itself out of mud or ditches. The combined pulling power of the rear winches was enough to drag a 45-ton tank out of a crater, up a slope, and onto the M15 trailer. The cable, hundreds of feet of heavy steel wire rope, was the lifeline that connected the recovery crew to the dead tank. When the winch engaged, the Dragon Wagon braced itself against the ground with its own weight and pulled with a force that could uproot trees. The M15 trailer was built by Fruhoff, the company that had essentially invented the American semi-trailer. It was an 8-wheeled flatbed rated for 45 tons with an adjustable loading ramp at the rear that could accommodate vehicles of different heights. The combined length of the M26 tractor and M15 trailer was over 17 meters, 57 feet, a footprint that made the Dragon Wagon one of the longest vehicles on any World War II battlefield. The Dragon Wagon required 7 men to operate. This was not bureaucratic waste, it was necessity. The driver sat in the left seat of the armored cab, peering through a windshield of bulletproof glass that was just wide enough to see the road and just thick enough to stop a rifle round. His view was terrible. The hood of the M26 stretched forward like the prow of a ship, the massive Hall-Scott engine hidden beneath it. He could not see the ground directly in front of the truck. He could not see the sides. He could not see behind. The vehicle had no mirrors that could survive 5 minutes on a battlefield road. He drove by instruction, by the voices of his crew relayed through the open top of the cab, shouting directions in a language of hand signals and profanity that was universal across every Dragon Wagon crew in the Army. The co-driver sat beside him, operating the front winch controls and handling communications. Behind the cab, 2 men managed the rear winches, massive drum assemblies that required constant attention during recovery operations. The cable had to be paid out evenly, the tension monitored, the drum brake adjusted to prevent the cable from bird nesting into a tangled mass that would take hours to clear. A steel cable under 60,000 pounds of tension is not a rope, it is a weapon. If it snapped, and cables did snap when they rubbed against a sharp edge or when a strand weakened from corrosion or fatigue, the severed end could cut a man in half. The winch operators knew this. They treated the cable with the respect a man gives a loaded gun. The remaining crew walked. They walked ahead of the tractor, guiding it through narrow spaces. They walked beside the trailer, watching the load shift. They walked to the disabled tank, crawling through mud or rubble to attach the towing cable to the hull's recovery points. They worked with their hands in conditions that ranged from merely miserable to actively lethal. Recovery operations were conducted close to the front line, sometimes within small arms range, always within artillery range. A Dragon Wagon crew working on a disabled Sherman in a Norman field in July 1944 could hear the machine guns chattering a quarter-mile ahead. They could feel the concussion of mortar rounds landing in the next field. They worked anyway because the tank had to be moved and there was no one else to move it. The men who crewed Dragon Wagons were not glamorous soldiers. They were not fighter pilots. They were not tank aces. They were mechanics and truck drivers and winch operators, men whose skills had been honed in the civilian world, in trucking companies, in logging camps, in the oil fields of Texas and the mines of Pennsylvania. They were men who understood heavy equipment the way a surgeon understands a scalpel, by feel, by sound, by the subtle vibration that told them whether a cable was about to fail or a chain was about to slip. They were the blue-collar infantry of the logistics war, and without them, the armored spearheads that captured the headlines would have ground to a halt within a week. The Dragon Wagon arrived in the European theater in late 1943 and early 1944, just in time for the build-up to D-Day. Approximately 9 were issued to each armored division, forming the backbone of the division's recovery and maintenance capability. The vehicle's primary mission was simple in concept and grueling in execution. Get to a disabled or destroyed tank, hook up the winch, drag the tank onto the trailer, and haul it to a repair depot behind the lines. This sounds straightforward. In practice, it meant driving a 57-foot, 21-ton vehicle down roads that had been cratered by artillery, through villages where the streets were narrower than the truck, under fire from snipers and mortars, to reach a tank that was sitting in a field that might still be mined. The recovery crew did not have the luxury of waiting for the battlefield to be cleared. Tanks were knocked out during the advance. The advance continued. The recovery crew came in behind the front line, sometimes barely behind it, and went to work. The winch operator paid out cable while the rest of the crew crawled to the disabled tank, attached the cable to the towing eyes, and signaled for the pull. If the tank was sitting in mud, the pull could take hours. If it was in a ditch, the angle had to be calculated to avoid flipping the tank onto its side. If it was on fire, the crew waited, but not long, because every hour a tank sat on a battlefield was an hour it might be hit again, stripped by scavengers, or buried by shifting terrain. The flames from the exhaust, the dragon's breath, were a real tactical concern. At night, the glow was visible for hundreds of yards.
Recovery operations conducted after dark required the crew to improvise exhaust baffles or simply accept the risk. Some crews stuffed wet rags into the exhaust tip, others welded makeshift covers. The Army eventually addressed the problem in the M26A1 variant, which featured an unarmored cab and various improvements, but the flame-belching exhaust remained a characteristic that defined the vehicle in the memories of everyone who served near one. In the hedgerow country of Normandy, the Dragon Wagon's size was both its strength and its curse. The vehicle could barely fit through the narrow lanes between the hedgerows. Crews became expert at threading the enormous tractor-trailer combination through gaps that seemed impossibly tight, guided by men walking alongside with hand signals, backing up and pulling forward in increments measured in inches. What should have taken minutes took hours, but the alternative, leaving knocked-out Shermans in the bocage fields, was worse. Every Sherman recovered was a Sherman that could fight again in days. Every Sherman abandoned was a weapon lost forever. During the breakout from Normandy and the race across France in August and September 1944, the Dragon Wagon's role shifted from battlefield recovery to strategic transport. The Army needed to move tanks hundreds of miles from rear depots to the front lines, and tanks that drove on their own tracks wore out their tracks, consumed fuel at ruinous rates, and chewed up the roads they traveled on. A Sherman driven 200 miles on its tracks arrived with its tracks fresh, its engine hours unspent, and its crew rested. The Dragon Wagon became the Armored Division's express delivery service. Fresh tanks from the ports, rebuilt tanks from the depots, replacement vehicles from the reserve, all of them traveled on the backs of Dragon Wagons and Diamond T transporters. The logistics of modern armored warfare depended not on the tanks themselves, but on the trucks that carried them. The Dragon Wagon was the unglamorous, oil-leaking, flame-spitting backbone of that system.
The Germans had no equivalent. This is not an exaggeration, it is a statement of logistical fact that shaped the outcome of the war. German tank recovery in the early war years relied on other tanks. A Panzer III would tow a disabled Panzer III. A Panzer IV would drag a Panzer IV. This consumed the recovery vehicle's tracks, engine hours, and fuel. When the Germans introduced the Tiger I, a 63-ton behemoth that was heavier than any towing vehicle in the German inventory, the recovery problem became acute. A Tiger could not be towed by a Panzer IV. It could barely be towed by another Tiger. Two Tigers towing a third Tiger was the standard procedure, and it consumed 3 combat vehicles to recover one. The Germans developed the Bergpanther, an armored recovery vehicle based on the Panther chassis, but it was never produced in sufficient numbers. It suffered from the same mechanical problems as the Panther itself, and it could not carry a disabled tank. It could only tow one, at speeds and over distances that wore the recovery vehicle as fast as it saved the patient. The result was a pattern that repeated across every front. German tanks that broke down, and they broke down constantly, especially the Panthers and Tigers with their overstressed transmissions and final drives, were often abandoned. Not because the crews wanted to abandon them, but because there was no way to recover them. A Panther that threw a final drive in a village in Normandy might sit there for days waiting for a recovery vehicle that was itself broken down somewhere else. When the Allied advance reached the village, the Panther was captured intact, studied by intelligence teams, and sometimes pressed into Allied service. The Americans, by contrast, recovered everything. A Sherman knocked out by a Panzerfaust in a hedgerow fight would have a Dragon Wagon crew on it within hours. The tank was winched onto the trailer, hauled to a depot, stripped, repaired, and returned to a unit, sometimes within a week. The Sherman that burned on Monday was fighting again by the following Monday. The German Panther that broke down on Monday was still sitting in the same field on Friday, slowly being buried by the advance of a war it could no longer participate in. This asymmetry, the ability to recover, repair, and return damaged vehicles to service, was one of the decisive logistical advantages of the Allied war effort. It was not dramatic. It did not appear in headlines. No war correspondent filed a story about a Wagon crew spending 6 hours in the rain winching a burned-out Sherman through knee-deep mud onto a flatbed trailer. But the mathematics were devastating. Consider the numbers. An American armored division in Normandy might lose 15 tanks in a week of heavy fighting. Of those 15, perhaps 5 were total losses, burned beyond repair, hit so badly that nothing could be salvaged. The remaining 10 were damaged but recoverable. Tracks blown off by mines, engines destroyed by anti-tank rounds that did not penetrate the crew compartment, turrets jammed by near misses. Wagon crews recovered those 10. The repair depots, staffed by mechanics who had been trained in Detroit and Pittsburgh and Cleveland, working with spare parts shipped from factories that were producing components 24 hours a day, had 8 of those 10 tanks back in fighting condition within 10 days. The division that lost 15 tanks on Monday had 8 replacements by the middle of the following week, plus whatever new production tanks arrived from the ports. A German armored division that lost 15 Panthers in the same week might recover 3 or 4 if the Berge Panthers were functioning, if the roads were passable, if the repair facilities had the parts. The rest were abandoned. 15 lost, 4 recovered, 11 gone forever. And the factories back in Germany, under constant Allied bombing, were producing Panthers at a rate that could not replace the losses. The arithmetic was a death sentence. Every week, the German armored force grew smaller. Every week, the American armored force replenished itself. The Wagon did not kill a single German soldier. It did not fire a shot in anger. Its sole Browning machine gun, mounted on a ring above the cab, was intended for self-defense and was rarely used. But by keeping American tanks in the fight, by ensuring that damaged machines were not abandoned but recovered, repaired, and returned, the Wagon contributed more to the destruction of German armored strength than many weapons that were specifically designed to kill tanks. Pacific Car and Foundry produced over 1,300 M26 and M26A1 tractors during the war. The Fruehauf Company built the M15 trailers. Together, approximately 2,100 complete M25 tank transporter systems were delivered to the Army. Pacific Car and Foundry did not disappear after the war. It evolved. The company that had built railroad cars and logging equipment and armored tank transporters pivoted to building heavy-duty commercial trucks. It changed its name. Today, it is called PACCAR Incorporated. It is the parent company of Kenworth and Peterbilt, 2 of the most recognized names in American trucking. Every Kenworth that hauls freight across Interstate 80, every Peterbilt that climbs the Rockies with a loaded trailer, every long-haul truck that carries the commerce of a continent on 18 wheels, they all trace their corporate lineage to a railroad car company in Renton, Washington that spent the war building armored monsters for the United States Army. The Hall-Scott Engine Company, which built the Wagon's 1,090 cubic-inch power plant, did not survive the peace. Without military contracts, the company declined and was eventually absorbed. The Nucky Truck Company of San Francisco, which designed the original prototype, faded into obscurity. The Fruehauf Trailer Company, which built the M15, continued as America's dominant trailer manufacturer for decades before eventually going bankrupt in the 1990s. But the Wagon's DNA lives in every heavy-duty truck on American roads today. The chain drive system, the extreme low-range gearing, the concept of a purpose-built heavy hauler designed to move loads that no ordinary truck could carry, these ideas, proven in the mud and fire of World War II, became the foundation of the American heavy-haul trucking industry. When the war ended, production of the Wagon stopped. The Army concluded that tracked recovery vehicles, armored machines that could go anywhere a tank could go, were better suited for battlefield recovery than wheeled transporters. This was true in theory. In practice, tracked recovery vehicles were slower, more expensive, harder to maintain, and consumed fuel at rates that made even the Dragon Wagon look economical. But the decision was made, and the Dragon Wagon was surplus. Hundreds of M26 tractors were sold to private operators. Heavy haulage companies in Europe and America bought them for pennies on the dollar and put them to work hauling transformers, bridge sections, industrial machinery, and anything else that weighed more than a conventional truck could carry. The legendary British heavy haulage firm Winches used Dragon Wagons for some of its most challenging moves, hauling power station equipment and factory machinery through the narrow streets of English industrial cities. The operators who drove them in peacetime discovered the same truth the Army had learned in wartime. The Dragon Wagon was uncomfortable, expensive to run, deafening, and utterly unstoppable when you asked it to pull something that nothing else could move. Some Dragon Wagons worked into the 1970s and beyond, their Hall-Scott engines still belching flame, their chains still throwing oil, their crews still nursing the enormous machines through jobs that would defeat anything smaller. The chain drive was the feature that civilian operators loved and hated in equal measure. It was powerful. The chains transmitted torque to the rear wheels with an efficiency and directness that no gear-driven axle could match at those loads. But the chains wore, they stretched, they required adjustment, and they painted every road they traveled with a film of oil that local authorities did not appreciate. A Dragon Wagon did not merely drive through a town, it left evidence.
The vehicle also served in Korea, hauling M26 Pershing and M46 Patton tanks to forward positions and dragging disabled armor back from the frozen ridgelines where the fighting raged. A few saw service on Okinawa in the Pacific Theater, where the salt air and tropical humidity tested every seal and bearing. But by the 1950s, commercially available trucks and trailers could match the Dragon Wagon's capabilities at a fraction of the operating cost, and the last military Dragon Wagons were retired. Today, surviving Dragon Wagons are among the rarest and most impressive military vehicles in private collections. Fewer than 100 intact examples are believed to exist worldwide. They're too large for most roads, too thirsty for most budgets, and too loud for most neighborhoods. Restoring one requires the skills of a locomotive engineer, the patience of a saint, and the financial resources of a small corporation. The Hall-Scott engine alone, 17 liters of American iron with 6 cylinders the size of coffee cans, fed by a carburetor the size of a man's head, is a restoration project that can consume years and thousands of dollars in machining and parts fabrication. But those who have driven one, who have felt the Hall-Scott engine shake the entire vehicle at idle with a vibration that comes up through the seat and into the spine, who have watched the flames shoot from the exhaust at night and understood why soldiers called it the Dragon, who have engaged the winch and felt 60,000 pounds of pulling force transmitted through steel cable to a dead weight that slowly, reluctantly, inevitably begins to move, describe the experience in terms that border on the religious. It is not a truck. It is a force of nature with a steering wheel. It is the physical embodiment of the American industrial philosophy that won the Second World War, the philosophy that says we do not build the most elegant machine, we build the machine that works. We build it bigger than we need to, we build it stronger than the specification requires, and we build enough of them that every damaged tank on every battlefield has a ride home. The Dragon Wagon taught the American military a lesson that sounds obvious but was, in 1942, revolutionary. The ability to recover damaged equipment is as important as the ability to destroy the enemy's equipment. A tank that can be repaired is a tank that fights twice. A tank that is abandoned is a tank that fights once. The nation that recovers its losses faster than the enemy recovers his will, over time, possess a numerical advantage that no amount of superior engineering on the other side can overcome. The Germans built the finest tanks of the war. The Tiger I, the Panther, the King Tiger, these were machines of extraordinary engineering sophistication, with guns that could kill at 2,000 yards and armor that could stop most Allied weapons. But they could not be recovered. When they broke down, and they broke down with a regularity that would have been comical if it had not been tragic, they were lost. The German armored force bled out through mechanical failure as much as through combat, and it bled without a tourniquet because there was no dragon wagon, no diamond T, no system for getting the wounded machine off the field and into a hospital. The Americans built tanks that were adequate guns, adequate armor, adequate performance. But behind those adequate tanks was a logistics system of staggering depth, a system that included not just ammunition and fuel and spare parts, but recovery vehicles, flatbed trailers, repair depots, spare engines, spare transmissions, and the crews trained to use them. The Dragon Wagon was the visible symbol of that system. It was the machine that said, "We do not abandon our equipment. We come back for it. We fix it. We fight with it again."
There is a photograph taken somewhere in France in late 1944 of a dragon wagon pulling a burned Sherman off a muddy field. The Sherman's turret is blackened, its tracks are hanging loose. A hole the size of a man's fist is punched through the hull where an anti-tank round entered. The dragon wagon's winch cable is taut, running from the rear of the tractor to the Sherman's towing eyes. The crew, 7 men in mud-caked uniforms, are standing beside the vehicle, watching the cable strain as the dead tank begins to slide through the muck. Nobody is shooting at them. Nobody is watching except a few infantrymen dug in along a hedgerow. No war correspondent is recording the scene. No general will mention this in his memoirs. This is not a moment of glory. This is a moment of work. Heavy, dirty, unglamorous work, performed by men whose names were never recorded, driving a vehicle that most histories of the war never mention. But the Sherman on that cable will be in a repair depot by tomorrow. It will have a new engine by the end of the week. It will be repainted, rearmed, recrewed, and back on the line by the middle of the month. It will fight at the Siegfried Line. It will cross the Rhine. It will be there when the war ends. Because the Dragon Wagon came for it, because a railroad car company in Washington state built an armored truck with a 17-liter engine and a 60,000-pound winch, because a trailer company in Detroit built a flatbed that could carry a tank, because the American military understood before anyone else fully grasped it that the war would be won not by the army that built the best tanks, but by the army that kept the most tanks running. The Dragon breathed fire, it leaked oil, it drank fuel like a furnace drinks coal. It was too big for the roads, too loud for the night, and too slow for the impatient. But it went where the broken tanks were, and it brought them home. And in bringing them home, it won a war that was measured not in individual battles, but in the relentless, grinding, unglamorous arithmetic of logistics, the mathematics of recovery, repair, and return. 57 feet of steel, chain, and noise, 7 men and a winch, and the knowledge that no tank, no matter how badly damaged, was ever truly lost as long as the Dragon could reach it.